All right, welcome to 12.1 notes. This should be for Silver 4. You're going to have a sub on Thursday, so this set of notes are for you. My expectation is for you to watch them via YouTube. I'll make sure I provide the link for you. But other than that, you can watch on your phone, take the notes. My notes will be on Blackboard as well, so you'll have both things for you. Be able to work on the homework, ask any questions at some point. I'll be in the building on Friday morning for blocks 1, 2, and 3. Hopefully I'm gone for block 4 once again because, you know, we won our first game on Thursday. So, here we go. We're going to do a little warm-up, and we're going to solve some equations to start with and get our brain going here a little bit, all right? So when I look at this, I have x squared plus 7 equals 43. So that is x squared plus 7 equals 43. And when I look at this, if I want to solve this problem, the first thing I'm going to do is I need to get, and I want to solve for x. So I need to get x squared by itself. So when I look at this, I need to move the 7 to the other side. Since it's a positive 7, I need to subtract 7. And subtract 7. What I do to one side of an equation, I must do to both sides of that equation. So when I do that, I am left with x squared equals 36. And then from here, I want x. I don't want x squared, I want x. And so when I see x squared equal to 36, I know that if I take the square root of x squared, that's going to give me x. So then if I take the square root of one side of the equation, I must do it to the other. And so I take the square root of both x squared and 36. When I do that, I'm down to now x on the left-hand side. Well, the square root of 36. Well, the square root of 36 is 6. But the reality is it's both plus and minus 6. It's both positive and negative 6. And I know this because, think about it, 6 times 6 is 36. But also, negative 6 times negative 6 is a positive 36 as well. So when I look at this, the square root of 36 really is 6, or x equals 6 or negative 6. I simply write it in the nice shortcut way, x equals plus or minus 6. All right, looking at the next one. Here we go. 64 plus x squared equals 164. When I look at this, I know that that 64 has to go to the other side. So I'm going to subtract 64 from both sides. And that's going to leave me x squared. Now if I have x squared, I take 164 and I minus 64. Well, that's going to leave me with 100. So I let x squared equals 100. Now once again, I have x squared and I want x, not x squared. So I'm going to take the square root of x squared. What I do to one side of the equation, I must do to the other as well. So the square root of x squared is x, and the square root of 100 is plus or minus 10. Now, evaluate for a equals 12, b equals 5, and c equals 13. So the first one, and this, remember, we're just trying to warm up here. I have a squared plus b squared. That's all I'm trying to do is figure out what is a squared plus b squared. Well, if a is 12, I want to go ahead and write 12 squared plus b is equal to 5, so I'm going to say 5 squared. When I look at that, 12 squared is 144. 5 squared is 25, so 144 plus 25. And what is 144 plus 25? Well, that would be 169. So I know that this one, a squared plus b squared, when a is 12 and b is 5, is 169. Now look at number 4 and it says c squared minus b squared. Well, c is 13, so I know that this is going to be 13 squared, okay, minus b, well, b is 5 once again, so that is 5 squared. Well, 13 squared, 13 times 13 is 169. 5 squared, once again, is 5 times 5, and that's 25. And 169 minus 25 is, you guessed it, 144. All right, so that's a little bit of our warm-up. Let me go ahead and erase it. Now, you can always pause this at any point. Pause it, play it back, anything at all. If I get going too fast, remember I'm not trying to make this a 35-minute video. So if I go too fast for you, you can always pause it, get caught up, rewind, any of that kind of stuff. All right. So the next one, we're going to talk about the Pythagorean Theorem. And the Pythagorean Theorem you all should have seen already. You've seen it before. It was last year for you in 8th grade. But here we go. Pythagorean Theorem. What is Pythagorean Theorem in symbol form? Well, it is a squared plus b squared equals c squared. Okay? Now remember, this is also kind of, some people will say this is short leg squared plus long leg squared equals hypotenuse squared. Okay? If you can remember a squared plus b squared equals c squared and know which ones it is, that is the way to go. Okay? Now, one of the things that we do is we only use the Pythagorean Theorem when we're dealing with a right triangle. A right triangle. And we know this because usually there is a box in the corner indicating a 90-degree angle. Okay, so Pythagorean Theorem, right triangles only. The next question, which of these variables represent the hypotenuse? Well, that's going to be c. Now, how do I find that? Well, it is going to be the longest side, but there's an easier way to do it than just trying to figure out which one is a little bit longer than the others. And that is, the hypotenuse is always across from the 90-degree angle. It's always across from it. So I know if I find the 90-degree angle, the side opposite is going to be my hypotenuse. All right. And then it says once you've figured out which is C, does it matter which leg is A and which is B? Well, that answer is no. It does not matter. Doesn't matter which one is A and which one is B. I could say this is A and this is B because that one is C, or I could vice versa. It does not matter. All right. So example 1. Steps to solve for a missing side of a right triangle using the Pythagorean Theorem. I've kind of labeled them out for you. Step 1, write the formula. Write it. A squared plus b squared equals c squared. That's step 1. Step 2, substitute the known values for the variables. Well, I know I have an 8, I have a 15, and I have an x. Well, the x is this side right here. I know that's my right angle. So that is my corner. So this has to be the hypotenuse. So either one of these can be A and B. I'm going to do the smaller one as A. The middle sized one is 15, which is B. And then I don't know C. So I'm going to use the variable that we have, which is X. Well, remember PEMDAS. I can't add 8 squared plus 15 squared the way it is. Because remember PEMDAS. Parentheses, exponents, multiplication, division, addition, subtraction, right? I need to take care of the exponents first. What that means is I need to square 8 before I add it to 15 squared. So 8 squared is 64. 15 squared is 225. And that is going to be equal to x squared. Now I can add these two together. This becomes 64 plus 225 is 289. And 289 equals x squared. Now I'm going to find x. I don't want x squared, I want x. So I'm going to take the square root of 289, take the square root of x, and now I know that x is equal to the square root of 289. Well, use your calculator to find that. If you can't find it, it is going to be your second button and your x squared to get to the radical. And once you do that, put 289 inside, hit enter, and you should see 17. So, the square root of 289 is 17, so I know that this missing side, the hypotenuse, x, is 17. All right, let's do one more of these. Example number 2. I have 6 and x and 14. Well, I see the 14 is opposite of this 90-degree angle right here. So I know that that is my hypotenuse. So write the formula once again. A squared plus b squared equals c squared. Now look at this, the smallest one, 6 squared. I don't know this, so that's x squared, because I had the variable x. And then I know my hypotenuse is 14, so sub 14 in for c and square it. Well, 6 squared is 36 plus x squared equals 14 times 14 is 196. And so when I look at this, I want x squared by itself, so I'm going to take 36 and move it to the other side. And that's going to leave me x squared equals 160. Now, take the square root of this, take the square root of that, and I need the square root of 160. Well, the square root of 160 is going to come out to be 12.65. Well, 12.65, if I round that to the nearest tenth, that ends up being 12.7. All right, that concludes the front page. Turn the page. Make sure if you pause it if you need to. Looking at any of this, I'm going to erase the board, but turn the page. So, here we go. Hopefully we all heard that the boys team, they took out the #1 seed today in the first round. So they're on to the semis. Okay, so make sure you cheering on the boys team. They won today. It says, suppose Frida's, Bert's, and Don's houses were located at these XY coordinates on the coordinate graph. You can generalize your locations by using the x1 coordinate, x2, y1, and y2, and solve for the distance between their houses. So Frida right here is the x1, y1. So you can see Frida here at x1, y1. Bert is at x2, y1. And then Don is at x2 and y2. And those are their points on the graph. And we want to use the graph to determine the distance from. Now notice this is a right triangle. Okay, I know this is a right triangle. This is a vertical line. This is horizontal. I know that if I have a vertical and a horizontal line intersect, then they form a 90-degree angle. Therefore, if it's a 90-degree angle in a triangle, this has to be a right triangle. Okay, so when I look at this, it says the distance, determine the distance from Don's house to Bert's house. Well, that formula, or that, I can't even think of the words, dB, I'm going to abbreviate to dB, from Don's house to Bert's house, thank you, dB. As I look at that, I want to go from Don to Bert's. So Don down to Bert's. Well, I know if that's a vertical line, I really just got to go the biggest number minus the smallest number. Well, the x's are the same, they're both x2's. I have a y2 and a y1. So my biggest number, y2 minus y1. Okay, the next part, Bert's house to Frida's house. Abbreviate that to BF, and that is equal to Bert's to Frida's. So Bert to Frida. Well, the x's are the same. I'm sorry, the y's are the same, but the x's are different. Bert is at x2, Frida's at x1. Bigger minus the smaller, so x2 minus x1. Now, use the Pythagorean theorem to determine the distance from Don's house to Frida's house. So Don to Frida. Okay, well I know if I want to use the Pythagorean theorem, that's a squared plus b squared equals c squared, right? Well, if Don's house to Frida's house is my hypotenuse of this, then I know that my abbreviation df must be squared, and that must be equal to my db squared plus my bf squared. Basically, this squared plus this squared. Make sense? Good. So now, what do I know? Well, I know that y2 minus y1 is the dB, and I know that x2 minus x1 is for bf. And I'm going to change the order of these. And remember, addition is commutative, so it doesn't matter which one and what order. But I know that df squared, I'm going to go ahead and put bf first. bf is my x2 minus x1. So, inside parentheses, x2 minus x1. Why am I putting it inside parentheses? Because I'm going to square all of that. And that is going to be added to my y2 minus my y1 squared. Now, I don't want df squared. Remember, in c squared, right, I've got to take the square root just to get to c, which is what we're finding here. So I'm going to take the square root of this, which means I've got to take the square root. When I do that, I know that df is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And what we have done here is we have taken the Pythagorean theorem and found the distance formula. We've discovered the distance formula by using the Pythagorean theorem. That is what this says right in here. You use the Pythagorean theorem to calculate the distance between 2 points on the coordinate plane. Your method can be written as the distance formula. The distance formula is d equals, so d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? That is distance. Let me scroll down a little bit because I got to erase here in a second. We'll go to number 11. All right. It says, do you think it matters which point you identify as x1, y1, and which point you identify as x2, y2 when you use the distance formula? Explain your reasoning. The answer is no, okay? The answer is no, and I'm going to show you why. I'm going to pick just 2 random points. So if I pick the point 10, 5, and I pick, let's say, 3, 6, okay? And I'm going to just deal with the x's here. Now remember, inside the formula, it's inside parentheses. So when I do this, if I use this is 2, the second one, the 3, 6 point is my 2, and this is my 1, I would say inside parentheses that this is 3 minus 10 squared. Well, 3 minus 10 squared really is a negative 7 squared, and negative 7 squared is 49. Now let's say that I thought it was different and I want to make the point 10, 5, 2 and my point 3, 6, 1. Well, what would I do? Well, I would simply do 10 minus 3 squared. When I do that, what's 10 minus 3? Well, it's 7. What's 7 squared? 49. You're going to notice that since I'm squaring the value, right, after the subtraction, that I'm squaring it, and get the same value. That's why it doesn't matter. All right, so it says calculate the distance between each pair of points. Round your answer to the nearest tenth if necessary. Show all your work. Here we go. I'm going to make these my 1s and these my 2s. And what I mean by that is my point 1, 2 is my x1, y1. And my point 37 is my x2, y2. So here we go. D equals the square root of, I still have the formula right up above, so you have it, you can see it. I'm just going to plug and go. My 2, x2, which is 3, inside the parentheses, minus my 1 squared plus 7, which is my y2, goes first, minus 2 squared. When I see that, I have D equals the square root. 3 minus 1, 2, plus 7 minus 2, 5 squared. The square root, 2 squared, 4 plus 5 is 25. 4 plus 25 is the square root of 29. Let me grab my calculator. The square root of 29 is 5.4. So D equals 5.4. So I know my answer to the first one is 5.4. Okay, B, negative 6, 4, 2, negative 8. To show you that it doesn't matter, I'm going to make these my 2's. So this is x2, y2. This is my x1, y1. Once again, plug it into the formula. D equals the square root of negative 6 minus 2 squared. And then I'm going to have 4 minus a negative 8 squared. Now you're going to notice that I wrote 2 minuses here. I do that because when I go back to check, know that 2 minuses, 2 negatives make a positive. 2 negatives make a positive, so I know that I'm going to end up making these both positive. Okay? And when I do that, if I go back and check my work, I can see that this was a negative 8 to begin with, and I can verify that I've done it correctly because this is a negative 8. Okay? So whenever I do this, I know that I started with this being a negative 8 and it was originally a minus. I would never write plus plus. That doesn't make any sense. But I know that it was a minus a negative if I do that. So here we go. D equals, make sure I'm switching to my markers here. Negative 6 minus 2 is the same thing as saying a negative 6 plus a negative 2. And that becomes a negative 8 squared. Plus 4 plus 8. Well, that's 12 squared. Negative 8 squared is 64. 12 squared, 144. Well, I know that that becomes 208. Now, the square root of 208, put it in our calculator. Square root of 208 is 14.4. That is 14.4. All right. Turn the page. Last page coming up. Last page. Here we go. Now, while I'm erasing, I want you to go ahead and start the last example, which is example C. I want you to do it on your own. I'm going to give you a few seconds. You might even pause here at this point, because as soon as I'm done, I'm going to give you the answer, and hopefully you're able to do it. You know you're doing it correctly if you get what I got. All right. So you should be working C right now. And when you look at C, you should get 8.1. So when you get done with C, you should look and get 8.1. All right, moving on. Number 13. It says, Carlos and Mandy just completed question 12, parts A through C. They need to calculate the distance between the points -1 and -2, and -3, -7. They note a similarity between this problem and part A. Carlos says that the solution must be the negative of the solution of part A of question 12. Mandy disagrees and says that the solution will be the same as the solution of part A. Who is correct? And explain your reasoning and state the correct solution. I want you to pause it. Try to work it out. I'm going to give you the answer here in 5, 4, 3, 2, and 1. Here we go. Mandy's right. And the reason Mandy is right is distance can never be negative. Distance isn't negative. So Mandy is the correct answer here. Mandy, is distance is not negative. Okay? So Carlos was incorrect. All right, last problem. Last problem. Here we go. A fun one. I like this. This might be something you would see on an ACT, state assessment. A really good problem. It's an application one. It'll be a little bit of fun. It says the distance between the point x2 and the point 0.6 is 5 units. Well, that is means equals. I got to think about that. Is equals 5 units. Use the distance formula to determine the value of x. Show all your work. Okay, so when I look at this, I know the distance. I want to use the distance formula. It tells me that. So d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, I'm going to plug and go. Distance between these points is 5 units, so I know that d is 5. It tells me that in the problem. It says, I want to do the x2 minus x1. I'm going to make this one my x2, y2. I'm going to make this one my y1. Well, x1 and y1. Getting ahead of myself there. So when I look at this, x2 becomes just x. x1 is 0, so x minus 0 squared plus my y2, 2 minus 6 squared. So I look at this, 5 is equal to the square root of x minus 0. What is x minus 0? Just x. So I know I'm x squared plus 2 minus 6. Well, that's negative 4 squared. So I know that 5 is equal to the square root of x squared plus 16. Now, some of you are going to think, well, I can just take this 16 from underneath this radical sign and subtract it out with this 5. Oh, no, you cannot. Okay, that's not possible. What I have to do is get rid of this radical before I do anything else, because these are tied together with this addition sign. So they're not separate. I can't just take the square root of 16 and say 4. I can't just take the square root of x squared and say x, because they're tied together. Okay? So when I do this and I see this radical, what gets rid of a radical sign? Just square it. So I know that if I square the left-hand side and I square the right-hand side, that I'm going to, in essence, get rid of this radical sign right there. So I know that 5 squared is 25. And the square root of the radical x squared plus 16 just leaves me x squared plus 16. In essence, all it did was take away the radical. Okay, take away to the square root. So when I look at this, now I want x by itself, so I need to take the 16 and subtract it. That's going to give me 9 equals x squared. Now you're thinking, I just got rid of a radical. The only way to do this is the square root. It is. The only way to get down to x is to take the square root here. I couldn't have done it over here though. I've got to do these separately, one at a time. Okay? So when I look at this, I need to take the square root of x squared and take the square root of 9. Well, I know the square root of x squared is just x. Well, I am dealing with distance, but I'm not really dealing with distance because I'm looking for a point on the graph. So in this case, the square root of 9 can be, it can be plus or minus 3. Because I wasn't finding a distance, I was finding a point on the graph using the distance formula. So I know that this point can be plus or minus 3. So to answer the question, what is the distance between these? Use the distance, the value of x. Find the value of x. Well, I know that the value of x can be 3, and the other point with it will be 2, or it's going to be negative 3, 2. And it goes along with this point 0, 6, and 0, 6. Now, if we were to use the distance formula and use both of these and plug them in, we would get 5 for both of them because it could happen at 3 or it could happen at negative 3. All right, this video took 31 minutes and 38 seconds. Hopefully you have a great Thursday. Cheers on. We're looking to beat Maze. All right, have a good day.